Hi everyone, so I'm back again with a new episode, and this time around this is the continuation of my previous video, which was on differentiation, basic differentiation formulas. So this time around I'm going to go over some different examples so that we could understand to some level. So for this question, I'm asked to find the first derivative and the second derivative of each function. So I'm going to start with this function, right? So I'm going to have my f prime of x, right? Now, in order to solve this question, I'm going to make it of my power rule and my addition and subtraction rule, right? Now, I have x to the power of 4, right? You correct that if I have my power rule, I have a to the power of b. This is going to become b, a, b minus 1, right? And that's the same thing that applies here. So my 4 is going to come down and I subtract from 1, right? So now I have 4x to the power of 3. My 3 is going to come down and I subtract from 1. So now I have 9x squared, right? And then I have an imaginary 1. I'm going to subtract from 1 and this comes down. So I have 16x to the power of what? Of 0. So now my f prime of x is 4x cubed minus 9x squared plus 16. Because x to the power of 0 is 1 and 1 times 16 is 16. Now, in order to find the second derivative, I'm going to have to find the derivative of my first derivative, right? So my second derivative is taking the derivative of the first derivative. That means I'm going to find the derivative of each term, right? So I'm going to have 3 coming down and minus 1. So 3 times 4 gives me 12 and I have x squared. My 2 comes down and I subtract from 1. So I have negative 18x, right? And to 16, right? 16 is a constant. And what is the derivative of a constant number? It's just 0. So that's it. So now my f prime of x is 12x squared minus 18x. So these are the answers for each one of the questions. So that's it. Now to the second question over here. I have h of t equal to the square root of t plus 5 sine t. The first thing I'm going to do here is I'm going to ask myself a question. Is there any way I could solve for t in a much easier sense? That means I'm going to have h of t, right? Now, t, the square root of t, is the same thing as t to the power of 1/2. Doing this makes it much easier for me to differentiate. So now I have plus 5 sine t, right? So my h prime of t is going to give me this. The 1/2 comes down and I subtract from 1. So I have 1/2 t minus 1/2, right? Now I have 5 sine t. Don't forget this is the same thing as 5, the derivative with respect to t, sine t, right? So I have h prime of t gives me 1 over 2 t to the power of negative 1/2 plus 5, right? What is the derivative of sine t? We collect its cosine what? It's cosine t, right? Now I can actually make this better. So I'm going to have h prime of what? Of t. I have my 1/2. Now whenever I have negative, it simply represents 1 over, right? And then I have t 1/2 plus 5 cosine t. This is equivalent to 1/2 the square root of t plus 5 cosine t. Right? Now, in order to find my second derivative, I have to find the derivative of my first derivative. Right? And if my negative 1/2 is going to come down and I'm going to subtract this from 1, I'm going to have negative 1/4, right? T to the power of negative 3/2, right? And then I have my plus 5. Now, what is the derivative of cosine t? It's negative sine t, right? So now I'm going to have h prime of t is equal to negative 1/4 t to the power of negative 3/2, negative 5 sine t. Now I can rewrite this as negative 1/4 times 1 over t to the power of 3/2 minus 5 sine t. So this is going to give me negative 1/4 the square root of t cubed minus 5 sine t. There's no problem with leaving your answer like this. This is absolutely correct. But this is also correct. It just makes it look neater, I think. So that's it. So I have a couple of questions, more questions to test our knowledge. I have a question that goes as y is equal to the square root of x minus 1, and y is equal to x squared plus 4x plus 3 over the square root of x. Right? Now, I can simplify the square root of x minus 1 as this. By now, you should know that the square root of x is x to the power of 1/2, right? And then I have x minus 1, right? So now I'm going to distribute x 1/2 into the bracket. So here I have an imaginary 1, right? So this is going to give me x. I'm going to have to add my exponent since I'm multiplying. So I have 1/2 plus 1, which gives me 3/2. And then I have x to the power of 1/2. I haven't found the derivative yet. All I did was just to multiply, just to simplify the bracket. Now I'm going to find the derivative of each term. So my 3/2 is going to come down and I subtract from 1. So I'm going to have 3/2 x 1/2, right? Here my 1/2 is going to come down, so I have 1/2 x negative 1/2. And this is the derivative of that function. Now, to this question, I have y equal to x squared plus 4x plus 3 over the square root of x. The same thing applies here. I'm going to have x cubed, or x squared plus 4x plus 3 all over x to the power of 1/2. Because the square root of x is x to the power of 1/2, right? Now I can divide each term. By x to the power of 1/2. So when I do that, I'm going to be left with x squared over x to the power of 1/2 plus 4x x to the power of 1/2 plus 3 over x to the power of 1/2. Right? So here I'm going to have x to the power of 3/2 because I'm going to subtract my exponents. Here I'm going to have 4x to the power of negative 1/2. Right? And here I'm going to have, it should just be 1/2 because this is 1, so it's 1 minus 1/2, which gives me 1/2. So here I'm going to have 3x to the power of negative 1/2. So I'm going to find the derivative of each term. So this comes down and I subtract from 1, right? So when that happens, I'm going to have 3/2 x 1/2 plus 1/2 times 4x negative 1/2 plus negative 1/2 3x negative 3/2. So this gives me 3 over 2 x 1/2 plus 2x negative 1/2 minus 3 over 2 x negative 3/2. Right? So I'm going to rewrite my final answer up. So I'm going to have 3/2 x 1/2 plus 2x negative 1/2 minus 3x negative 3/2. And this is the derivative of this function. That's it. So this is the conclusion of the first episode. I hope you guys were able to understand the step-by-step differentiation of each function. And I hope to see you guys in the next video. Thank you and have a lovely day ahead. Bye.